Unit 3, Lesson 1, Simplifying Radicals. So a radical is a symbol that represents the square root of a number, or think of it as an expression with a square root in it. Now, I want to remind you what perfect squares are. So perfect squares are numbers that when you take the square root of them, the answer is a whole number. For example, 4 is a perfect square because the root of 4 is 2. Okay, so 2 times itself is 4, and that makes 4 a perfect square. So I've listed a bunch of perfect squares from 1 to 121, and I want you guys to get comfortable solving these without using a calculator. Okay, so go ahead, pause the video, and try and figure out the square root of all these numbers. I think it'll be easier than you think. Okay, so there's the answers. So let's just dissect the word perfect square again. So 121 is a perfect square because when you take the square root of it, you get a whole number, which is 11. This means that 11 times 11 is 121. Okay, let's go ahead and solve the square root of 3 times 16. So in the past, you would have taken the square root of 3 and got a decimal, and then the square root of 16 is 4. In grade 11, when you take the square root of something and get a decimal, I want you to leave it as just a radical, okay? Because by changing something like root 3 into its decimal form, you lose a bit of accuracy because you're going to round, okay? So leave it as root 3 because root 3 is not a perfect square. Okay, so we leave this as root 3, and then we can solve for the square root of 16, so it's 4. Okay, so the answer here is 4 root 3. Okay, take a second here. Play around with these expressions. Okay, is the square root of 24 the same as taking the square root of 4 and multiplying it by the square root of 6? Notice that 4 times 6 is 24, so that means 4 and 6 are factors of 24. Okay, once you've figured that out, ask yourself, is the square root of 24 the same as taking the square root of 2 and multiplying it by the square root of 12? Again, 2 and 12 are factors of 24. Okay, so pause the video and see if you can figure that out. Okay, so you would have realized square root of 24 is 4.9, and then when you take the square root of 4 and multiply it by the square root of 6, you also get 4.9. Okay, so this one worked out. Let's try this one. So we know the square root of 24 is 4.9 by plugging it into our calculator. And then when you take the square root of 2 and multiply it by the square root of 12, you also get 4.9. So the reason why I want you guys to try this out is because I wanted you to realize that if you have the square root of a number, it's the same as taking the square root of its factors. So you can always divide up a whole number that's under the radical into its factors, each underneath a radical. Okay, so in summary, taking the square root of the factors of the original number is the same as just taking the square root of the original number. You get the same answer. And we're going to use that for simplifying radical expressions. Okay, so in example 1, I want you to simplify all of these radicals without using a calculator. So when you have something like root 24, and you can't just figure out the square root of that in your head, what you want to do is you want to use what we discovered before. Let's break down 24 into factors where one of them is a perfect square. Okay, so what times what is 24? Let's go, 1 times 24, 2 times 12, 3 times 8, 4 times 6. Which of those factors is a perfect square? 4 is the only perfect square here. So if we break down root 24 instead into root 4 times root 6, which we know we can do because of what we discovered here, now this is a lot easier to solve, right? Because we know root 4 is equal to 2, and then we leave root 6. So it's really nice if you can break up a value into factors where 1 is a perfect square, because then you can simplify a lot easier. Now let's check, can 6 be broken down into factors where 1 is a perfect square? Okay, the answer is no, so we know we're finished. Because this is as far as we can go without a calculator and with keeping perfect accuracy, right? We don't want to change that root 6 into a decimal because we'll lose some accuracy by rounding. Okay, so part B, root 32, we cannot do easily in our head, so let's ask ourselves, what factors can we break 32 down into where 1 is a perfect square? Okay, let's do 16 times 2 because 16 is a perfect square. And then we know that root 16 is 4. Root 2 stays as root 2 because we cannot solve that easily in our head, and we know that's going to be a decimal. So we're finished here because we can't break any of these down further into perfect squares. Part C. Some of you right off the bat will say, well, we can break down root 36 into the product of root 9 and root 4. And then they're both perfect squares, so it's 3 times 2 which equals 6. And that's great, but those of you who can recognize a perfect square right off the bat can actually take a shortcut, right? It is actually not necessary to go through all that because 36 is a perfect square right at the beginning. Square root of 36 is 6, you're done. Okay, root 75. Okay, not a perfect square. We can't do that in our head easily. So let's see if we can break it up into factors where 1 is a perfect square. So we can break it up into root 25 times root 3 because the root 25 is because 25 is a perfect square. Okay, let's try this one. So we don't know root 45 off the bat. So let's go ahead and break it down into factors where 1 is a perfect square. So 9 and 5. And then we can break down square root of 9 because that's a perfect square. And then we are finished. Okay, so adding radicals. This is the first time we've done this. I want you to think of this as the same, instead of saying 2 root 3 plus 5 root 3, it'd be the same as doing 2x plus 5x. Okay, think of that root 3 as like a variable. Okay, and when we add terms like 2x plus 5x, we can do that because they're like terms, right? This would equal 7x. Well, it's the same when adding radical numbers. To add or subtract radical numbers, you need like terms, meaning they need to have the same radical. So because this is 2 root 3 plus 5 root 3, those are like terms. We can add these together and produce 7 root 3. Root 27 plus root 12, those are not like terms. They are different radicals. So when that happens, let's try and simplify. Okay, so instead of writing root 27, let's go ahead and write root 9 and root 3. We're breaking it down into its products, where 1 is a perfect square. And we can break root 12 down into root 4 root 3. Again, 4 is a perfect square. Now this becomes 3 root 3, and this becomes 2 root 3. Now we have like terms because they both have a radical of root 3. So our final answer is 5 root 3. Okay, 4 root 8 minus 3 root 18. We cannot simplify that as is because they're not like terms. One has a root 8 and one has a root 18. So let's break down those radicals. That's always what you do when you don't have like terms. So instead of writing root 8, I'm going to go ahead and write root 4 times root 2 minus, let's break down root 18 to root 9 root 2. Now let's simplify those perfect squares. Root 4 is equal to 2. Root 9 is equal to 3. Now let's simplify by multiplying our numerical coefficients. So 4 times 2 is 8. Root 2 is still there. 3 times 3 is 9, and again that root 2 is still there. Now we have like terms. They both have a root 2. So let's go ahead and subtract these terms. So just remember, when you're adding or subtracting radicals, you can only do so if they have like terms. If not, try and break down the radicals into factors where one of the factors is a perfect square. Okay, example 3. So when we have root 6 times root 10, we're essentially given the factors, right? We can multiply those together, right? It's just like instead of writing root 24, we broke that up into root 6 and root 4. Okay, that's 6 times 4, and you can move backwards. Okay, you can move both ways. So essentially in this question, we're given the factors, and we can multiply them together to combine the terms. So this would be equivalent to root 60, okay? And one of the reasons why we want to do that is because we can't really simplify these guys any further, right? We can't break those down into factors where 1 is a perfect square. So now that we have root 60, there's more of a chance of us breaking down that root 60 into factors where one of the factors is a perfect square, right? Because we can divide that into root 15 times root 4, and now 4 is a perfect square, so we end up with 2 root 15. Okay, let's try this one. So first ask yourself, can we break these numbers down into factors where 1 is a perfect square? Okay, we can, right? We can't do anything with root 3, but we can change root 27 into root 3 times root 9. Okay, so then we get root 3 times root 3, and the square root of 9 is 3. And then, so we can't break down root 3, so let's multiply them together. So root 3 times root 3 is the square root of 9, and then we know the square root of 9 is 3, so we just end up with 3 times 3, which is 9. So that's one way. Some of you might have noticed another way to do this. Okay, instead of breaking down 27 right off the bat, you could have multiplied root 3 times root 27 together. So let's do it that way. So root 3 times root 27 is equal to the square root of 81. 81 is a perfect square. So we get 9 again. So this way was just a little bit quicker if you noticed that. Okay, so you can either choose when multiplying radicals to just multiply them together straight off the bat, or break them down into factors where 1 is a perfect square. It's just whatever's easiest for you. Okay, 4 root 12 times 3 root 18. So I want you to ask yourself, what can root 12 and root 18 be broken down into such that one of those factors is a perfect square? And then go ahead and simplify. Okay, pause the video and try that on your own. Okay, so hopefully you got to this step. Now, some of you might get a little confused here and think, can we combine 8 root 3 with 9 root 2? And remember, if those two terms were being added and subtracted together, you could not, because you need like terms to add and subtract. To multiply, though, we can go ahead and combine these two terms through multiplication, right? Multiply your numerical coefficients together, and then multiply your two radicals together. Okay, so you're going to do 8 times 9, which is 72, and then root 3 times root 2 is root 6. And that's as far as we can go, because we cannot break down root 6 into two factors where 1 is a perfect square. Okay, example 4 shows you how to use the distributive property when there are radicals present. So the first thing you're going to do is multiply that root 3 by the 2, and then you're going to multiply the root 3 by the root 6. So root 3 times 2, we can't actually do because 1 is a radical and 1 is not a radical. So this just becomes 2 times root 3, okay? We didn't do anything there. Now, when you multiply a radical, so root 3, times another radical, root 6, you can combine those. So that actually becomes root 18. Okay, so you can only do that when both numbers are radicals. You cannot multiply together a radical with a number that's not a radical. Okay, let's go ahead and see if we can break any of these radicals down into factors where 1 is a perfect square. So there's nothing we can do with our root 3, but we can divide up root 18 into root 9 and root 2. And then this becomes 3 root 2. Okay, that's as far as we can go. We can't add these two together because remember, when adding or subtracting radicals, they need to have like terms. And these are not like terms because one has root 3 and one has a root 2. So we're just finished there. Okay, part B, we're going to use FOIL to solve this. So we're going to do 2 times root 3 and then 2 times 4 root 5, negative root 5 times root 3, and negative root 5 times 4 root 5. So 2 root 3, we can't combine those because they're not both radicals, so we just write it as 2 root 3. And then 2 times 4 root 5, we can multiply the numerical coefficients together because they're both just integers. Okay, so that becomes plus 8, and then we have our root 5 there. Okay, negative root 5 times root 3, they're both radicals, so we can combine that. It becomes negative root 15, and negative root 5 times 4 root 5 becomes negative 4 root 25. Okay, multiply together numerical coefficients and then multiply the two radicals together. Now let's see if there's any like terms, and there's not right now because they all have different radicals. So ask yourself, can you break any of these radicals down into factors where 1 is a perfect square? Okay, you cannot do that with root 3, you cannot do that with root 5, and you cannot do that with root 15. So the only thing we can simplify here is 25 is a perfect square, so let's go ahead and simplify that. And that's as far as we can go because we don't have any like terms and we don't have any radicals that we can break up into factors where 1 is a perfect square. Okay, so how is being able to simplify radicals a useful skill for us? Okay, so this is not factorable by any of the methods like difference of squares, decomposition, etc. So we have to use the quadratic formula. So here's the quadratic formula. Okay, and then we plug in our A, B, and C values. Remember, this is our A value, this is our B value, and this is our C value. And then we would simplify. Now, in the past, you would have just plugged this into your calculator and got a decimal. But unfortunately, you're losing some accuracy by doing that. So now that we are comfortable simplifying radicals, let's use our methods from above to simplify this. Okay, so instead of writing root 8, we can break it down into factors such that 1 is a perfect square. Right? It's the same as root 2, root 4. Okay, and then we can divide each term by 2. So let's break this down into our two answers. Okay, so first, x could equal 2 plus root 2. Second, x could equal 2 minus root 2. So those are our two roots. Okay, and you can see that that is a perfectly accurate answer because we kept our radicals in place. And you're able to do that now after this lesson.